And then Vahid, you can get started with your presentation. Thanks very much.
You're welcome. May I start now?
Yes, please go ahead.
Okay, thank you so much. Okay, thank you for your attention. And Alex, thank you. I wanted to thank Dr. Irannezhad, Dr. Kakelman, and everyone else who helped us to organize this webinar. Macro-scale evaluation of urban transportation demand management policies in CBD by using system dynamics. It is done by me, Ms. Shahrzad Khosravi, and Dr. Hossein Haghshenas. Well, everyone nowadays knows about the congestions of the highways and roadways. And everyone knows that there are several ways of solving this problem and reducing the congestion. One method is to reduce to add new roads and highways, and the other way is using new policies and managements. Everybody knows that adding new roads and highways is a really excellent way to reduce the congestion, but everyone should know that it has some disadvantages, like more air pollution, more fuel consumption, and more laziness and lower health conditions of the society. So it is much better to use new policies management. Policy management has to be assessed in several ways. One way to assess the policies of transportation is to traditionally manage, and one way is to innovatively manage the transportation policies. So we have two choices: traditional policy management and innovative policy management. Traditional policy management is are appropriate for a partial analysis in traffic area zone levels. Let me see. Require extensive data collection and only could be used to evaluate and compare a few number of demands. So it is not a suitable way to manage the policies. In this paper, system dynamics modeling has been used to evaluate the transportation demand management policies. So it is much better to use an innovative policy management, which is completely comprehensive and can be used to assess numerous policies together spontaneously. So, what is a system dynamic modeling? System dynamic modeling is a suitable method for long-term macro-scale evaluations of different policies with various indicators, because in this method, causal relationships between variables and their feedbacks are considered, as well as its dynamic approach, not needing detailed information in traffic area zones. And the possibility of evaluating different policies makes the system dynamic modeling a better way than traditional ways of policy assessment. In this research, the encouraging and restrictive policies were used to form policy packages that can be inserted to the central business district of Isfahan city. Urban transportation causal loops were conceptualized, and the dynamic relations among urban transportation variables were created to develop the pertinent urban dynamic model. There are some encouraging policies that we use, including improving the bus and taxi services, completing metro network development, which is under construction at the moment, improving bicycle facilities, encouraging people to carpool. There are some restrictive policies that have been considered in this research, including carbon prices, increasing parking prices, and odd and even restrictions. These are some policies that we want to assess. We want to understand which of them is better, and what way is better. There is a better way to apply these policies. For example, combining them together and making combined packages of policy. We call them in this research as policy packages. Also in this research, main indicators of of the transportation policies assessment is included of air pollution, energy consumption, and traffic mobility. Of course, there are other indicators that can be used to assess the transportation policies, but in this research, we decided to choose the three most important. Alex, there's something happening right here. Can you see that? Okay, in this research, we decided to use three most important indicators of transportation policy management. One, air pollution, two, energy consumption, and three, traffic mobility. How to build a system dynamics model? The elements of the dynamic system model include independent variables as causes, dependent variables as effects, and arrows indicating the relationship between cause and effect. The relationship between these variables results in the formation of feedback loops. In general, the process of constructing dynamic system models consists of three phases of conceptual modeling. Conceptual modeling, flow diagram, drawing, and development of a dynamic system model in one of the dynamic system softwares. In this research, we decided to use VenSim software to establish our model. So we have three main elements: independent variables as causes, dependent variables as effects, and arrows indicating the relationships between causes and effects. First step is to conceptual modeling, is to establish a conceptual model. Then we need to draw a flow diagram. We will see a flow diagram, examples of flow diagram in future, in upcoming slides. And then we need to develop a system dynamics model. This totally includes the process of constructing dynamic system models. Okay, this is a picture of Isfahan city, my hometown, where this project has been established. The dynamic model of this research shows that the relationship between transport variables in Isfahan city at macro scale levels using the VenSim software. The central district considered for this study is as seen in figure 1. You can see the figure 1 in the picture. The trips that are either originated or destined in this area are examined in this study. The historic center of Isfahan, with its attractive travels, offices, businesses, educational and medical facilities, attracts around 400,000 daily trips to this. The limited capacity of the central city streets cannot meet the demand for the attracted trips, and urban managers have turned to demand management policies. So it is really important to find a way to assess the policies, the future policies. Okay, this is a diagram of VenSim. This is what you see when you open VenSim and create your project. The causal relationships, rings, and variables are made for this research are as seen in figure 2. You can see figure 2 here. Input variables are colored yellow and output variables are colored green. So these are input variables, and we don't have any output variable here because we don't have any green squares, you know. Okay, all of these three variables have a direct relationship with the total travel demand. Population variable increases with a certain growth rate in future. Also, car ownership rises at a definite rate, and this rate will slowly increase over time as car ownership increases. You know, when car ownership increases, when the population grows and the car ownership grows, so these two have a positive correlation. The total travel demand of this city is divided into two segments of demand for travel to the central area and travel demand for non-central areas. So these are the two types of trips that we have considered in this research. This is another view of the Vensim software at the ultimate levels, you know. These green squares are outputs and these are the inputs.
Looks like we had some
Alex,
issues with Vahid.
yeah, Alex, can you hear me?
Yes. Yep.
Yes, yeah. I'm so sorry. Sorry for any inconveniences. Okay,
No
let's
problem.
continue.
Yep.
Sorry. Transportation modes. Four types of transport, as described in the figure 3. You saw the figure 3, are discussed for this city. One of them is private car trip, including motorcycles. Number 2, taxi trip. Number 3, bus trip. And number 4, railway trip. This is another view of Vensim software, a causal diagram of model outputs. And this is the last model that we had in the Vensim software. Now, I want to introduce my mathematical equations of the model. These are some examples of mathematical equations used in the research. You can use the full edition of the paper to have access to the details of the equations. Again, this is another examples of the equations. Some of these relationships were derived directly from definitions of variables, and in other cases, mathematical relationships between variables were logically assumed to dominate a mathematical relationship. The mathematical relations presented in this study are based on logical relationships, regressions, on results of the simulation relationships presented in the past studies, and available information from Isfahan municipality. You know, there was a comprehensive report of transportation in Isfahan, which was conducted by Isfahan municipality, and we used the output information of this report in this study. Okay, you can see two diagrams. These are only two diagrams of the results of this study. You look at here, regressions in result of simulations. This diagram shows that by increasing the car equivalent demand of CBD, total traffic volume of CBD increases. You know, it's kind of obvious. You know, look at here. This is a diagram of CEDC to CTVC. Okay, look at here. You can find that here. Oh, I don't have the slide, but you can find them in the full edition of the paper. CEDC stands for car equivalent demand of the CBD, you know, and CTVC means total traffic volume of CBD. Okay, so when the car equivalent demand of CBD increases, obviously total traffic volume of CBD increases. Okay, this is obvious. And the other one, PCSP. PCSP stands for private car average speed in the CBD. Private car average speed in the CBD here. And CEDC is again the car equivalent demand of the CBD. So what do we have here? When it says when it is inferred from this diagram that when by decreasing private car average speed, by decreasing private car average speed, when the average speed decreases, the car equivalent demand of CBD increases. You know, it says if the cars go slowly in the streets of CBD, then we need more space for the cars. If they drive faster, we need less space in the streets for the cars. Yeah. Okay. These are just only two diagrams, but there were about 40 parameters like CEDC and CTVC in this research, and for all of the 40 parameters, we drew these diagrams, and finally we got the results. And transportation demand management policies modeling. We used some policies like bus services improvement of bus services and BTR network development simultaneously. Number 3, taxi services improvement. Number 4, cardon pricing policy. Number 5, parking pricing policy, and some other policies. You can see them in the slide. These are some of the policies that can be combined with each other to form policy packages. And eventually, every policy package will be assessed. So let's get to the results. Okay, look at this table. Look at this table. The values of output indicators in the 2025 and the rating of policies. In this table of results, you can see the results of inserting every policy package, finally by normalizing the results and by scoring them. We can find out which of the policy packages is the best one to be applied in the CBD of Isfahan. You know, we had 3 main indicators: air pollution, energy consumption, and traffic flow. And again, I'm really sorry for any inconveniences. Sorry, I couldn't get my VPN connected, so this happened and I had to use my cell phone. Okay, I hope you can see these numbers. Okay, air pollution will be the amount of air pollution which is produced daily in this region of the Isfahan is here, right here. This is kilograms of CO2. And the normal variable is mentioned underneath the line, okay? And, you know, this thoroughly shows that which policy is better than other policies. And this table helps us to score the policies that we have considered in this research. For example, metro network development. This is the score. This is the normalized value in the year 2025, and this is for energy consumption, and this is for traffic flow. Eventually, from this table, we can infer that this is a table of scores. The score of every policy package can be seen in this table. As a result, the most effective policy for this region, which leads to reduced congestion in the CBD of Isfahan, is to develop the subway system in this city, respectively improving bus services and other policies. Okay, look at here. The best score is possessed by metro network development. What does this mean? What does this mean? This means that metro network development is the most effective policy that can be used in the city to reduce the congestion in the streets, okay? And respectively improving bus services considering BRT lines, improving bicycle facilities, car pricing for central area, increasing parking prices, and etc. Okay, so now we know which policy best fits this city in accordance with people's behavior and other factors. Okay, this is the diagram that shows the results of the previous table. Okay, what is this? Another output of this paper is the analysis of policy packages. You know, we can combine some of these policies, for example, developing metro networks and also developing bicycle facilities, for example. So this is a policy package, you know, which includes two policies. This table, in fact, shows the scores of different policy packages. For example, the best policy package, completion of metro network development plus carbon pricing for central area. This policy package, which is combined of two policies, gets the best score, and this is number one. This is not a rank of policies, this is ranked one. So this is the best policy. This is the best way we can reduce the congestion in the CBD area of my hometown, Isfahan. Okay, these are also these can be also beneficial for this purpose, but the rank of this policy is much better. So if there is one decision that decision makers need to make, that should be completion of metro network development plus carbon pricing for central area. In other priorities, they can improve bus services, including BRT lines, plus carbon pricing for central area, and etc. And other policy packages. All of them can be beneficial for the city, but this one is much better than others. And at last, thank you for your attention. And I'm again sorry for any inconveniences. Thank you, Alex, for managing this meeting for us.
Great, thanks so much.
You're welcome.
Are there any questions for Vahid?
Yes, anybody have a question?
Yeah, so for folks that have joined late, the way that we're going to do questions is mostly through the chat window. If you'd like to be unmuted and if there's time, we can unmute you to engage in some discussion with the presenter as well. And we did get off to a bit of a late start. So I'll just wait a minute to see if any questions come through. And
fine.
We're going to have Yeli present next, and we couldn't get her audio working, so we're just going to play her pre-recorded PowerPoint file once we transition. Well, I'll ask a question, Vahid. What is the most important thing that we should take away from your work? If there's just one thing, a key takeaway, what would it be? Okay, you know, everybody knows that these policies are beneficial for reducing the car congestion in the streets. But the most important thing provided in this research is that I have provided an innovative way using Vensim software to assess policies that we can apply to a city. For example, in my country especially, they don't have any plans, they don't have any aims, they don't have any goals to do something. First, they do something and they wait to see the advantages and disadvantages. You know, they never calculate, they never kind of research what the outcomes will be. You know, this way, I have so many sessions with the municipality and mayor of Isfahan to make him understand that this is a good way to predict the results of a project applying to a city. And I hope this will work in future, you know. That's great.
This is the most important thing. Yes.
Quite a different context from the United States, where we do have lots of sophisticated travel demand and land use models and lots of modelers and practitioners operating them and trying to understand the impacts of policies and plans.
Yes, yeah.
But politics still gets in the way. So it's not, even though we have, very sophisticated modeling tools, there's still a lot of other factors that bear on the decision-making process.
Yes, you are completely right. Yeah, you are completely.
We have another question from Deb Niemeyer in the chat. She asks, are health and air pollution effects integrated in the planning process?
Excuse me, I couldn't hear you again. Would you please repeat it?
Yeah, the question, you should be able to see the chat box too. It just, Deb Niemeyer asks, are health and air pollution effects integrated in the planning process?
Yes, of course. Yes, of course. Okay, we have considered air pollution, three main factors: air pollution, traffic mobility, and what was the other one? Let me see. Traffic mobility and energy consumption. When applying policy on a city, it will change the situation. A good policy makes a good change. My research helps us assess the change. When we, for example, want to encourage people to carpool, carpooling, the situations change when, for example, 100 people use their cars. For example, suppose that 100 people use their cars to go to their workplaces, and for example, the day after, just 20 of them use their cars to go to, for example, their workplaces. The other 80 cars have used carpooling policy. So this changes the situation. This makes the air pollution, this causes introducing less air pollution. This causes decreased car congestion in the streets and other advantages and disadvantages. In this research, we have developed a way to assess these changes. So when we use VenSim software, we can assess these changes together in, for example, in future 10 years, 10 upcoming years. And we can also assess numerous policies together. So this is one way to make my research kind of innovative and useful.
Great, thanks so much. So I think that we will move on to the next presentation now, which was actually listed as our first presentation. So this is Ye Li.
Hello everyone, my name is Ye Li. I'm a second-year PhD student from the University of Sydney. Today I'm going to talk about my current research, integrating the dynamics of boundary queues in perimeter flow control. There are another two authors, Dr. Mehmet from the University of Queensland and Dr. Mohsen from the University of Sydney. The overview of my presentation is first I will give you a brief introduction of the terminologies used in this research and the paper framework of this research. Then I will talk about the motivations and contributions of the research. Next, I will mainly talk about the methodology part, which is including one region and two region model based on macroscopic fundamental diagram. Especially in two region model, I will introduce 4-state and 6-state accumulation-based MFD. Finally, I will show the results and future works. Okay, now let's move to the introduction. Well, in this part, I will introduce some terminologies. The first one is accumulation-based and trip-based MFD. For the accumulation-based MFD, as you can see in these figures, it describes a nonlinear, low-scattered relationship between production or trip completion rates and vehicle accumulation when the spatial distribution of congestion is homogeneous. Whereas the trip-based MFD, it describes a well-defined relationship between regional speed and vehicle accumulation of a network. The trip-based MFD considers traveler details such as travel length, departure time, etc., whereas the accumulation-based MFD is a parsimonious model, which assumes all vehicles with the same travel length. The next one is perimeter flow control. Well, it's a kind of control strategy that always applies at the region boundaries. As you can see in this figure, U12 denotes the perimeter flow control from region 1 to region 2. It monitors the traffic inflow to region 2 in order to keep the vehicle accumulation in region 2 under a certain value. And the next one is boundary queue dynamics. Well, it considers queuing vehicles in packs as they occupy road space and influence the traveling vehicles. As you can see in this figure, there are queuing vehicles near boundary. When a vehicle joins boundary queues, it will be subtracted from the traveling accumulation but added to queuing vehicles until it leaves the queue. For example, vehicle I from region 1 to region 2. First it is traveling vehicles in region 1 and then queuing vehicle in region 1, and finally becomes traveling vehicle in region 2. Well, we assume that the vehicle is only queued once in the studied period. Okay, now let's move to the paper framework. Well, in this research, we developed an accumulation-based MFD model with unknown parameters. By unknown parameters, I mean the accumulation fractions from region 1 to region 2 is equal to the number of accumulations from region 1 to region 2 over the total accumulation in region 1. This is the assumption in the accumulation-based model, but we will release this assumption by introducing unknown parameters. Then the controller will be designed based on the accumulation-based model. This is the main part of this research and is an ongoing step, and we will finish it later. So finally, when we got the controller, we can apply it in the trip-based model. The trip-based model is used as a plant to get more realistic values of accumulation fractions. Actually, the development of accumulation-based model and trip-based model is finished. And as I mentioned previously, the controller will be finalized after this conference. Okay, now let's move to the motivation and contribution. Well, the research is motivated by the two shortcomings of current literature. The transfer flows in the accumulation-based model are based on the assumption of homogeneity amongst the destination of the trips. So the corresponding contribution is that we release this assumption by using trip-based model to get more actual values of accumulation fractions. Another shortcoming is the trip-based model does not consider boundary queued vehicles. But in our research, we're concerned about queuing vehicles in a two-region network. Okay, now let's move to the methodology. Well, in this part, I will introduce one region MFD model. We assume the well-defined MFD exists in the studied network, as shown in the figures. The fundamental equation of accumulation-based MFD is shown here. It means the accumulation at time t is equal to the inflow minus the outflow of that region. So the inflow is the generated demand, and the outflow is the trip completion rates. For the trip-based model, we calculate the travel lengths of individual vehicles from their different departure time to the arrival time by using the current mean regional speed. So each vehicle has a specific travel length in the trip-based model. Well, we understand the fundamental relation in one region network, and it was developed by previous research. Now let's talk about the two-region network. Well, the large urban area with uneven congestion distribution. We can divide the heterogeneous network into two homogeneous networks, and each with a well-defined MFD. But for two-region model, we consider more traffic states such as traveling vehicles and queuing vehicles. From Ni and Cassidy in 2009, we separately considered queuing vehicles. The original MFD should be rescaled. As the figure shows, the jam density becomes original jam density minus the number of queuing vehicles. So if there are queuing vehicles, the MFD is downsized, as the dashed line shows. The rescaled procedure could be happened in each time step if there exist the queuing vehicles. Once there are queuing vehicles, we need to consider the number of vehicles that pass the boundary. This should be the minimum value between boundary capacity and the number of vehicles from region 1 to region 2. It means if the number of vehicles from region 1 to region 2 is less than the boundary capacity, then the vehicles don't need to be queued at the boundary. So if there is no queuing vehicle, we can get the conservation equations of four-state accumulation-based model as follows. Well, here I just used the variables relative to region 1 since the equations for region 2 are very similar. For example, you can see that the number of accumulation from region 1 to region 1 at time t is equal to the demand minus the outflow, and then plus the inflow of region 1. So Q in these equations means the demand, and theta is relative to the accumulation fractions, and P tilde is the rescaled MFD. So here is the four-state accumulation-based model. And if there are queuing vehicles, we can get the conservation equations of six-state accumulation-based model as follows. For example, in these equations, the upper T means the traveling vehicles and Q means the queuing vehicles. For example, dN12T over dt is the number of traveling vehicles from region 1 to region 2 at time t is equal to the demand minus the outflow. And then the number of queuing vehicles from region 1 to region 2 at time t is equal to the outflow minus the number of vehicles that pass the boundary. So we can get the six-state accumulation-based models. Well, in our research, we applied four-state accumulation-based model because the controller will be designed based on the accumulation-based model. If we use six-state model, The optimization problem is very complex since the uncertain parameters will be included in the optimization equation. So we choose the four-state accumulation-based model. And for the trip-based model, we consider the individual travel lengths. For example, the travel length of vehicle I travels inside region 1 is equal to the current mean speed times its travel time. The travel time of vehicle I is from its departure time to arrival time. Similar of travel length of vehicle I from region 1 to region 2. But we consider the join queue and leave queue time when vehicles travel between regions. Okay, now we have already done introduction, motivation, and contribution, and also methodology part. Now let's move to the results. Well, let's see the results of the case with or without boundary queues. The initial conditions for both cases are shown here. The initial accumulation of region 1 and region 2 are 2,000 and 2,500 vehicles respectively. And the generated demands are shown in the left figure. We also run a test with a large number of vehicles to get the trip length data. And the distribution of trip length is shown in the right figure. As you can see in the figure, L11 and L22, or L12 and L21 have very similar distributions respectively, since the network is schematic. So let's see the case that is not considered queuing vehicles. The accumulation evolution are shown in the two figures, and the left figure is from accumulation-based model, and the right figure is from the trip-based model. This is a relatively simple example to check the consistency of the two models. From the figure, we can see that the trip-based model reacts immediately when there are demand surge, whereas the accumulation-based model reacts moderately. We also run another test considers queuing vehicles. The accumulation evolution as shown in the two figures. As expected, when there are demand surge, the trip-based model reacts more immediate than accumulation-based model. Also, as you can see, the number of queuing vehicles in the trip-based model, even though it's very small, but in the accumulation-based model, we cannot see the number of queuing vehicles. So there is a slight change when the queuing vehicles exists the boundary queues. The accumulation in trip-based model increased slightly, whereas we cannot observe this phenomenon in the accumulation-based model. So in other words, the trip-based model will be more accurate than accumulation-based model. For the future works, we will finalize the controller design. The model includes uncertain parameters such that the controller will be robust to deal with model with uncertainties. Or maybe we can apply another control approach like pricing. But yeah, we will consider this works after this presentation. Okay, that's all. Thank you.
Okay, thanks, Ye, for the presentation. Our next presenter is going to be Louis Merlin. He's going to be presenting his work on a new method using median travel times to calibrate single parameter spatial interaction models. And Louis is at Florida Atlantic University. So Louis, I can unmute you, and then hopefully you can share your screen. But I think we have a PPTS file for you as well if needed. So you're unmuted, you should be able to talk now.
Okay, can you hear me?
Yes, I can.
I'm working on sharing my screen.
Yep, I can see it.
Great. So we're good to go then?
Yep, take it away.
Okay. As Alex just mentioned, my name is Louis Merlin. I work at Florida Atlantic University. I want to thank the organizers of this conference. I think it's, of course, this is the first year, but this is an excellent idea to have a carbon-free conference, and I definitely support this effort and appreciate all the work that went behind making this happen. I'm going to talk about median calibration of single parameter spatial interaction models. So my agenda, try to keep this quite simple. The gravity, I want to talk about the gravity formula for spatial interaction models and in particular accessibility, how it links to accessibility, which is really how I got into this question. I'm interested in accessibility-based performance measures, and that's how I got into this question of how to calibrate these models. Then some theoretical inspiration and some thought experiments on why the median turns out to be important. And then finally, some simulations, some Monte Carlo simulations of the method to see how effective it is. So because of the nature of the conference, I didn't want to assume much in terms of background. For some people, this is going to be quite basic. For other people, it may be new. I wanted to start with just the basics of the gravity formula. There are many kinds of spatial interaction models, and gravity-based spatial interaction models are only one of the many types. There's the, I'm forgetting the other names of the other models now. The intervening opportunities model, there's some other models as well. But the basic concept of gravity models is that we can create an analogy with the way physical gravity works. And that is that spatial interactions become more likely with larger size of either the origin or the destination, and they become less likely with greater distances. So it's a nice physical analogy for how spatial interaction works. The general formula for spatial interaction I'm showing here at the top. Tij is we can imagine a number of flows from origin I to destination J. It's going to be directly proportional to the size, the number of travelers leaving origin I, the number of travelers arriving at destination J, that's the OI and the DJ, and a function of the cost between I and J. Here I've expressed, the second equation expresses the cost in the most common way that it's done, which is the negative exponential formula. So cost, the cost function is a negative exponential, so as cost increases, the likelihood of interaction decreases. And then the beta is the impedance coefficient, and this is the whole research question behind this paper is how do we determine the beta. What's interesting to me is I've read a lot of papers on accessibility that use this formula, and very often they don't even explain where their beta comes from. Sometimes it's just we accepted this value from another paper, or we just set this value fixed. The number of papers that explicitly explain how they determine their beta is actually a minority of papers. So this got me interested in this question. Now I do want to say that there are well-defined methods for calibrating the beta or any number of parameters, but I'll go into the issues with those methods in a second. So why care about this impedance coefficient? Well, of course, spatial interaction is, for people in transportation, useful for trip distribution models. It's also useful for understanding patterns of migration, patterns of social interaction, and even economic transactions. The more philosophical question here is, what is the cost of distance? How much does increasing distance impede the possibilities of interaction? And of course, to understand accessibility, we need to understand that factor, that impedance coefficient. To have an accurate estimate of accessibility, we need to have an accurate estimate of how much distance or cost matters. To go into a little bit more refined definition of gravity-based spatial interaction models, technically there are 4 flavors of such models: the unconstrained, the production constrained, the attraction constrained, and the doubly constrained. In the unconstrained model, we don't know the exact numbers of flows from any origin or destination. And the production and the attraction constrained, we know either the number of people leaving each origin or the number of people arriving at each destination, and we can use that data to more accurately calibrate the model, fix the number of people leaving or a particular origin or arriving at a particular destination. The doubly constrained model is constrained at both the origin and the destination. So we know the number of people leaving every origin, we know the number of people arriving at every destination, we can constrain both, and this gives us a much more accurate model. Doubly constrained models are more accurate not only in terms of their prediction, but in terms of their behavioral description of impedance. So the doubly constrained model is kind of the gold standard for gravity-based spatial interaction models. Now, the disadvantage of the doubly constrained model is that we have many more constraints. All of the AIs are origin constraints, the BJs are destination constraints. We have to have one for every origin and every destination. And so you have to calibrate all of those constraints, and that basically makes it a very data-hungry procedure to calibrate these models. So this diagram, this simple diagram, this conceptual diagram, gets to the essence of the difficulty of the widely accepted method for calibrating the doubly constrained spatial interaction model. And this method is largely due to a Hyman paper from 1979. It's in my references at the end. So you basically have to go through a double iterative loop to calibrate this model. The first part of the loop is on the left-hand side. You start with a rough estimate of the impedance value, and you use that impedance value the impedance estimate to calibrate each of your balancing factors, all of your AIs and BJs for every origin and destination. Well, the AIs and the BJs are also interdependent. So then you have to go over to the right-hand side and do a loop, estimate your origin constraints, and then estimate your destination constraints, and go back and forth. So for a typical full calibration of a doubly constrained model, you might go through the iterative loop on the left-hand side 10 or 15 times, and you might go through the iterative loop on the right-hand side 100 times for each of those 10 or 15 times. So you can see that this becomes a rather cumbersome process, a lengthy process. If you have travel demand management software, all of this can be automated, but not everyone has such software, and setting up this process from scratch is quite taxing and challenging. So what are the problems with this double iterative loop? So it does work, it does produce accurate results, but it is complex, and it typically requires either expensive travel demand modeling software to get an accurate result. I've calibrated these models in open source R software. If you do it kind of by hand, like I'm doing it, it can be time consuming. Calibrating one of these models can take an hour or so of computational time. Very heavy data requirements for calibrating such a model. It doesn't handle small data sets well, because each origin and each destination constraint basically it consumes a degree of freedom. And if you have any zero flows or misestimated flows in your model, it can throw off these origin and destination constraints. In particular, if you have a destination that has no flow into it, the model will assume that no destination flow is possible, that destination constraint is zero. So it's very data demanding and complex. And this begs the question of, why do we need so much analysis when in reality we're only trying to estimate, often only trying to estimate a single parameter, which is the beta. You only need a single parameter for the typical negative exponential model or the typical power formula. So are there any fast, simple, and reasonably accurate alternatives? Interestingly, there is a fast, simple, and alternative, which is the trip length distribution method of calibration, which I'll talk about very briefly because I'm just using it as a method of comparison. But in the research that I've done, I haven't come across a theoretical justification for the trip length distribution calibration. It's very widely used. You can find dozens of sources and citations that use the trip length distribution method. But nevertheless, I haven't come across a theoretical justification for this method. And so if someone on the call or on the conference has one, I would love to get a hold of it. So next I want to transition to the theory behind the median method, do a little bit of a thought experiment to inspire the method. So in this diagram, we're basically supposed to consider each orange dot as an origin. Each orange dot is an origin, and we're imagining people leaving their origins and how long does it take them to reach their destination. So maybe in the first 5 minutes, one traveler reaches their destination, and then 2 more reach their destination in 10 minutes, and then 3 more in 15 minutes. And then by the time we reach 20 minutes, exactly half of travelers have reached their destination. In other words, we've reached the median travel time. So the median travel time is the time at which half of travelers have reached their destination and half have yet to reach their destination. So why is this important? Following this thought experiment. Basically, the reason this thought experiment is important is that if we imagine all travelers leaving their origins at the same time, the median travel time is that for which the average traveler has reached half of the destination opportunity, because half of the travelers have reached their destination and half have not. So if we sum up the destination opportunity reached by the average traveler by the median, that's going to be equal to the average destination opportunity reachable after the median. So this basically yields an equation that we can use to solve the impedance parameter. And I do want to tip my hat to the I can't say his name right, but the US paper that first caught me on to the possibility of a median method. So this gives us a very simple equation. The left-hand side is the sum of the destinations reachable for up to the median travel time for 1, 2, 3 minutes up to the median travel time. Say it's 20 up to 20 minutes times the impedance function for each of those travel times. That should be equal to the destination opportunity reachable at more than the median travel time times the impedance formula for those longer travel distances. And so to find the impedance parameter, we just need to find the beta that minimizes this difference function. And the delta t's are simply the sum of the average destination opportunity reachable for each minute from the average traveler from their origin. So this, because there's only a single minimization equation here, this only works for single parameter impedance functions. So now I want to go into the Monte Carlo simulations of the method and how well it works within these simulations. So what I did is for negative exponential and power functions for a range of impedance values, for each impedance value, I generate 100 simulated cities. Why simulated cities and not real cities? I had that question from a couple of reviewers. There's 2 reasons why I wanted to use simulated cities. One is, with real world cities, we don't actually know what the true value of the impedance is. With a simulated city, I can basically generate a city with a known value of impedance and then try to recover that. So I have a true value to compare my estimate against. The second reason, of course, is with a Monte Carlo simulation, you can run dozens or hundreds of simulations and therefore test the robustness of the method across many different cities. So I've used a conceptually simple city, 20 by 20 zones, with the travel time to adjacent zones is about 5 minutes with a little bit of randomization thrown in. Population and employment are randomly distributed across these zones. And as I said at the beginning, I create a true known impedance value. Then I fit a doubly constrained model to each simulated city. So the flows are based on these underlying assumptions: the known impedance value, known locations of population and employment, and then I use the median method to try to recover that known impedance value. And I compare it to two other methods: the trip-length distribution method that I mentioned before, and an alternative median method due to OS. So this just gives you an idea for what these simulated cities look like. The population distribution for an example city is on the left. It's normally distributed. Basically, the population is pretty much always between 800 and 1200. On the right, I've distributed employment exponentially, so we've got much more concentrated employment. Most of the zones have virtually no employment, and some of the zones have large amounts of employment, such as 4,000 or 6,000. I thought this created a more realistic test for this model, having uneven distribution of employment. So this is a bit of reiteration of the method, except for, in this case, I'm demonstrating the method for a specific case. Basically, what you need to do is you need to create a table of the number of destinations that the average traveler reaches for each minute of travel, and then determine the impedance coefficient that balances the accessibility reached by the median travel time with the accessibility that's reachable after the median travel time. And this table basically details how I go about doing that. The rows are the origins, the columns are the minutes, and in each cell I have the number of destinations from every origin that are reachable within 1 minute, within 2 minutes, within T minutes, up to capital T is the maximum number of minutes in the system. So creating this table is basically a crucial building block in the process. Again, a bit of a reiteration here, except for I've substituted a specific function here for the impedance function instead of a general function. I'm using here specifically the negative exponential function. I just seek to minimize this difference, find the beta that minimizes this difference. The two comparison methods that I'm using, one is the trip-length distribution method, which is basically fitting a log function to the number of travelers within each bin. So the number of travelers who have traveled 3 minutes to their destination, 4, 5, 6, and so on. You have to throw out the zeros because you're fitting a logarithmic function to that. And the OS method is even simpler than my method. It's just take the natural log of 0.5 and divide by the median. He justifies this method in his paper. It has some theoretical justification, but practically it turns out not to be that accurate. So now for some results. First, I describe the results in summary form, and then I go into a couple of tables. The proposed method, the proposed median calibration method, outperforms the alternative fast methods. Typically, the error in the estimated impedance values are small, less than 10%, for common values of the power and exponential functions, but there is some variation, and I've seen errors as high as 27%. And in fact, the error of the impedance estimate systematically increases as the true impedance value becomes higher for the exponential function. So this table is probably the most important summary table. In the first column, I have the true impedance value for the negative exponential function. In the second column, I have the mean median estimate across 100 cities. The third column is the mean error for the median method. The fourth column is the mean error for the OS method, and the fourth is the mean error for the trip-length distribution method. I have highlighted in orange all places where the mean error for the median method is greater than 10%. So we see a systematic increase in the error as the true impedance value gets higher. And then likewise, a similar table for the power function. The OS method isn't applicable, so there's just two methods of comparing here, the median method and the trip-length distribution method. The trip-length distribution method performed very poorly for calibrating power functions. I'm not exactly clear on why. The median method almost always performed within 10% of the true value for the power method. Another question is, how accurate is the sample median to the true median, since you need to know the median travel time to use the median method? I had assumed that sample medians were going to be very accurate with small samples, but one of the reviewers challenged me on that, and so I actually looked at my data and did a simulation of how accurate is the sample median to the true median, and it turns out it's less accurate than I thought. This shows a range of impedance values and a range of sample sizes, and how often the sample median is within 1 minute of the true median. And as you can see, it's dependent on both sample size and the impedance value. For large impedance values, the sample median is fairly accurate. For small impedance values, the sample median isn't as accurate. Generally, the rule of thumb I'm recommending here is to have a sample of about 200 to get a good sample median estimate. So we've covered a lot of territory here, but I just kind of want to review what makes this contribution important. I think this method makes the calculation of gravity or potential accessibility much more accessible, much easier to do. You don't have to have specialized travel demand modeling software to calibrate the impedance parameter. What do you need to know? You need to know the origins, the destinations, the travel costs, and an accurate estimate of the median. You don't need to have detailed origin-destination flows, unlike for the doubly constrained model. No double iterative loop is required. The method is faster and less complex than the Hyman method, which of course is very good if you have complete data. I did this analysis in R, but I do believe that all the steps are possible in spreadsheet software, which again should make the method more accessible. And lastly, because the median can be estimated with smaller data sets, I believe that we can identify accurate impedance parameters for special modes, such as walking, biking, and transit, and for special groups such as immigrants. And just to give you an example, I was recently looking at a data set in South Florida. The total number of transit trips they had in for the travel demand survey was 230. So using the traditional method, I wouldn't have been able to accurately calibrate the impedance parameter, but using this method, I could. So some key references. All of these are great references. Fotheringham and O'Kelly is kind of the Bible of spatial interaction models. The Hyman paper of 1969 is still to this day very useful on the calibration, the full method for calibrating doubly constrained spatial interaction models. So that's really the end of my presentation. I did want to point out that I have a book on shifting to accessibility in transportation planning, so I just kind of wanted to do a brief plug for that book. So thank you. I'll take questions at this time.
Thanks, Louis. Any questions for Louis? Feel free to put those in the chat window. Okay, one from Matt Conway. So Matt asks, how do the impedance values estimated from the median method compare to an impedance value estimated using an unconstrained model?
Okay, I think I need to stop sharing in order to, I can't see the question, so. Can you still hear me?
Yep, yeah, you're good. So Matt Conway and Eli Irannezhad have questions. Can you see the chat?
Yeah, I see the chat.
Great, cool.
That's a really good question. So Matthew's question is how does using the median method compare with an estimate using an unconstrained model, right? Because you don't need a big data set to estimate an unconstrained model because you're only estimating a single parameter. That's an excellent question. I haven't done any analysis. I think it's probably very context dependent. What I will say is when I've seen previous studies that examine the doubly constrained versus an unconstrained model, the doubly constrained, usually the impedance parameter with the doubly constrained model is quite different than the unconstrained. So I think that's going to be very context dependent, but I think it's going to be more accurate than an unconstrained estimate. Could your model possibly capture the variation in congestion by peak hour? Yes. So the answer to that is, so if we imagine that people's willingness to deal with travel time changes over the hours of the day, this method could take into account differences in impedance by hour. So, for example, we could get a median travel time for the peak hour and a median travel time for the off-peak, and also origins and destinations for peak and off-peak, and we could calibrate the model with both of those data sets and see if there's a difference. We could see if there's differences in impedance by time of day. So that's exactly one of the values of this method, is you don't need these super large data sets to give it a whirl.
Louis, this is Alex. I have a quick question too. So one of the benefits of your method seems to be that the computation time is dramatically reduced. I'm wondering if you could just give us a sense of how long our implemented methods take relative to doing this in like Transcat or Cube with the doubly constrained.
You mean so you know, when I've used Transcad to calibrate the models, you get it in seconds. I have to say, you know, it may be completely accurate, but they don't really tell you what's going on under the hood there, which makes me a little uncomfortable. So you know, what the real apples to apples comparison is my own experience in R. So to calibrate a doubly constrained model in R typically would be about 1 to 2 hours. And to do it with the median method would be about 5 or 6 minutes. So that would kind of be the apples to apples comparison.
Got it. Yeah, that makes sense.
But in Transcad, when you calibrate these models, it only takes seconds. It's very, very fast, and it may be completely accurate. I can't say for sure.
Right. So that's the benefit of the open source approach.
Yes. The open source is, you know exactly what's happening.
Great.
And I want to say that this is going to be published in the Journal of Transportation and Land Use, Journal of Transport and Land Use, and the R code will be published with the paper.
Great. Any other questions for Louis? If not, I'll thank Louis for your presentation. Yeah, go ahead. Can you share your screen?
Yes.
Perfect.
Just let me second. Yeah.
Great.
Can you see my screen?
Yep.
Okay.
Perfect. Go ahead.
Yeah. Thank you so much. Hello everyone. Hear me on the Bridging Transportation Research Conference, January 2020. First of all, I should give my thankful for those who try hard and put a lot of efforts in this conference, especially Professor Kockelman and as I know, Elnaz and you, Alex. Thank you so much for all of your efforts. My name is Milad Delavaryforoutaghe. I am now presenting the study the time lag cross correlation between rural and urban off-road traffic mortality by multivariate time series in Iran. Our study period is 2009 to 2016. Our authors for this paper, beside me, Zahra Ghayeninezhad, Abolfazl Mohammadzadehmoghadam, and Vahid Fakoor. This is one of our paper that will be published and the result of my master's thesis. In this paper, I will tell you a little about the literature review of this study, and then I will talk about how we collect data, where we collect our data, and then we talk about the methodology and the theory, and I mean the statistical analysis and modeling for this study, and then we go to the results and see what will happen. Okay, let me to say about just some facts of World Health Organization WHO reports. As you know, 1.25 million road traffic mortalities occur per year. It's a kind of disaster across the board, and first cause of deaths between ages 15 to 29. As you can see, these figures in middle income countries with green color, in low income countries with yellow color, we have high road traffic fatalities. For example, if you look at the right figures, you can see that just almost 25% of all of the road traffic mortalities are just occur in low-income countries. And then we have middle-income countries. Iran is in middle-income countries, so it's a kind of important, important subject for just focus on our road traffic injuries, mortalities, and casualties. If you look at this map, you can distinguish and you can know better that, for example, in Africa, we have just 26% of road traffic fatalities. And in Eastern Mediterranean, like, for example, in Iran, that is in Eastern Mediterranean, we have 20% of all of the words. I mean, road traffic mortalities. And WHO reported that 3 out of 4 persons for deaths is related to men, and also vulnerable users. I mean, motorcyclists, as you can see here, and bikelists and those who are walking are the most in danger. I mean, in roads across the board. We should focus on it. But let me to explain more about road traffic mortalities in Iran. Iranian traffic police in 2018 say that in each year, I mean, just let me to say just for 2018, we have 15,000 mortalities in road traffic mortality across Iran. So it's kind of, as I said, this kind of disaster just for Iran. And the total cost of the total amount of cost of these mortalities. For example, we have a manual. I mean, highway safety manual that published in US. In that manual, say about how we can calculate these costs, but the total amount of cost is $420 million. Is equal to 6% of our GDP, especially in Iran. Just in Nowruz holidays, Nowruz holidays is the holiday of New Year in Iran. Each one person lost his life each 58 minutes. I mean, almost 1 hour we lost one person in 2019. And we have 15 days of holidays in Nowruz. And in the first 15 days of New Year, we lost 374 Iranian. As you can see, this figure, Iranian rate of road traffic mortalities per 100,000 people. You can see that, for example, in just 2016 and 2017, 1.6 and 1.5 deaths we have per 100,000, and this is an incidence rate of road traffic mortalities, total road traffic mortalities, and I explain you in later that how we calculate incidence rate. But let me say more about the literature of our methodology. We use time series modeling, I mean SARIMA modeling, because of its predictability and rich information in time-dependent changes. Because of these, as I said, predictability and rich information that we have in time-dependent changes and time series, the SARIMA model has kind of superiority over other predictive methods. For example, like, a set space methodologies or neural network. As you can see in this table, Bahadori used SARIMA for predicting road traffic mortality in Iran in 2011. Delavary used SARIMAs for incidence road traffic injuries, total road traffic injuries, and especially for males, females, and males to females that published in PLOS ONE 2019. And also Zhang used SARIMA for predicting road traffic mortality in China and published in, as I remember, in Annals of Epidemiology 2015. But beside of forecasting, we can use time series modeling or interrupted time series modeling for intervention analysis. For example, for know the impact of law enforcement or legislation. For example, Jones, Lee, Steinbach, Olsen used interrupted time series in these years just to know how much is the effect of laws which is related to U.S. child safety seats or marginal restriction on fatal crashes in U.S. and neo-urban mortality extension and so on. So we have a lot of studies during, for example, the last decades that use interrupted time series to know the exact impact of traffic intervention. And this is another application of time series. Let me to explain more about our data collection. We collect data, but let me to say how we publish our time series. We use incidence. But why we use incidence? Here I want to compare incidence with prevalence rates. We use incidence rate and prevalence rate in epidemiology studies. And just let me to show you this picture. Incidents are related to those cases which are new. For example, as you can see here, new water. But prevalence is related to both new and old cases. But here in traffic safety, we say new mortalities, new injuries for just a given period. For example, how many mortalities we have in January, for example, in Iran. This is new, okay? So we use incidence rate. But what is the definition of incidence rate? Incidence rate is related to new cases, for example, casualty, deaths, injuries. That is divided to, for example, population per population. This population is calculated average monthly population over a given period. For example, in this study, we publish time series monthly, the monthly data. We use mortality data in three categories: rural areas, villages areas, and urban areas. But let me to explain more about these areas. When we say urban areas in this study, we say just those highways that we have in our city, yeah, like all the countries. But when we say about rurals, we mention those roads, those highways between cities, I mean between states, or we say interstates. And about villages, we just say about local, rural, or those who are in village areas. We got and collect these data from Iranian Legal Medicine Organization, LMO. As I said, we collect monthly total urban and rural and village mortality of road traffic accident in Iran just between March 2005 to February 2016. And we use incidence rates. So incidence rate, the definition of incidence rate is mortality to average of monthly population. Monthly population, average monthly population, and incidence rate, the definition is the population in the middle of the month. So it's better, definition. It's accurate definition. In order to get the monthly population of rural, urban, and village areas, I mean time series, we use total population for rural, urban population for urban, and village population for village, respectively. In this study, we use data from a national organization for civil registration. But in Iran, we have a shortage, lackage of monthly, population. So how we collect these data? We just calculated monthly population by aggregating the population of previous months with the number of births and deaths which reported by national organization, as I said. So we had births and deaths time series, and we used them in this study. And as I said, we reported per 100,000 people. As you can see, this time series, we examine, we evaluate these time series in our study. This is the incidence rate of total road traffic mortalities. This is related to our villages, this is related to our urban, and this is related to rural. You can see the trend of all of these mortalities, that we have a kind of reduction in our mortality during these 6 or 7 years. But let me to explain more about these 2 last years. You can see a constant trend, yeah. This is related to, that we have 2 interventions in our traffic, law enforcement. One of them is, I think, occurred here, and one of them occurred here. And I will publish this paper in +1, and this is this paper revised, and the name of this paper is the impact of law enforcement on road traffic mortality and injuries. In that paper, I said that here, the second intervention, that is the increasing of, the increasing of the money that people could pay for their offenses and violations, traffic offenses. Here, we don't have any changes significantly, and the impact of that intervention do not happen significantly at 5%. But let me to explain about the methodology. We use Box-Jenkins methodology the first step of Box-Jenkins methodology is stationary. First of all, if we see a time series, we should check the variance stationary. What is the meaning? What is the definition of the variance stationary? If you look at the variance of these time series, you can find that the variance change during this period, and the variance reduce. So this is not a stationary, and we should use, for example, logarithmic, as you can see, the red one, or a squared, to just change this time series to a series, as you can see here in a red line, that the variance is constant and stationary. So this is the first assumption of Box-Jenkins method. The next one is mean stationary. What is the meaning of mean stationary? Here in this time series, we don't have any stationary in mean. What is the meaning of a stationary in mean? We don't have, when we have a trend here, you can see we have a trend for incidence rate of urban road traffic mortalities. So when we have a trend, we can say that this time series is not stationary in mean. So we use different, first lag and 12 lag. This is related to our trend. This is the first lag that is related to our trend, and we can stationary in trend. And if we want a stationary which is related to our season, we can use 12. 12 is our season in time series. But what we need to say about the season? Season is a period of time that is less than 1 year. So in here, because we use monthly data, so the season is 12. Each 12 months are repeated, as you can see here. But another this or Dickey-Fuller test. The hypothesis of this test is that the H0, the hypothesis is that the time series is not stationary. For example, here you can see that incidence rate of urban road traffic mortalities accept hypothesis. So the time series is not stationary in mean. We use differences 1 and 12 to make it and change it to stationary in mean with this value that accept our hypothesis. Also, we can use Kinon to know about the validity of linear model. As you can see here, our Solomon model, this is a univariate Solomon model, but in this I want to focus about multivariate Solomon. In this study, we use a Solomon model, univariate Solomon model with PDQ and PDQ capital letter with a Solomon model as season. You can see this parameter which is related to month graph. If we have this ACF and PACF in this graph is are one, not SARMA, are one. I just exemplify my mythology, this mythology. And these are moving average. R is autoregressive, MA is moving average. This is related to non-seasonal, and this is related to seasonal. Let me to say about this theory that we use in this study. The previous page was related to univariate SARMA, but here we use multivariate SARMA, or SARMA with S season. The matrix version of its SARMA is as below. Here you can see we have two time series. These coefficients are related to autoregressive. This is related to y1t, and this is related to y2t time series. And these are related to moving average. These coefficients are related to their own, just autocorrelation between in one time series. But if we have a mutual correlation, we should have this coefficient significantly non-zero, as for example 5%. If just we have one of these coefficients significantly non-zero, so this is dynamic regression. This is not mutual. Both of our time series are not correlated mutually. Just one time series affect another one. This is dynamic regression, and this is responsible variable. This is explanatory. These are explanatory variables, and this entity is error term that we can use SARMA instead of entity.
Hey, Milad, this is Alex. Just about a 5-minute warning.
Yeah. Shortly, let's take a look at the result of multivariate time series analysis. As I said, these coefficients and these coefficients, the p-value of these coefficients and these coefficients are less than 5%, and so our correlation between rural and urban time series are significantly correlated. For accepting these models, we should check the white noise of residual. We use Legend box for check the uncorrelation of residual, and as you can see, for 24 lags of the residual, we can accept the uncorrelation, and also zero mean, we find zero mean of our residual, so we accept the white noise of our residual. You can see the prediction of urban and rural of time series in Iran with multivariate. You can see the changes and variation. Because we use multivariate, we use more information and detail. So you can see more detail on the prediction of these time series. Also, the best fitted, as you can see, blue line is predictive valuable, and black line is the actual valuable, and the green line is the 95% of confidence interval. So you can see the best fit of the blue line to the black line, and also the prediction accuracy of these time series for rural and urban. You can see that, for example, root mean square, mean average error, or mean average percentage error, all of them accepted. And finally, I want to explain shortly about the result. We use multi-ARIMA model to predict road traffic mortalities of urban and rural areas. Just let me to say that we evaluate village to rural and village to urban to see these time series have a kind of mutual correlation, and we don't find any mutual correlation, or just single correlation, I mean dynamic regression for a village, between village and rural and village and urban. So we I mean, we don't have any result of village in this study. As you can see here, we have prediction values of rural and urban areas in Iran. So, for example, if we know how many mortalities we have in 2024, so we can use traffic safety policy making to reduce it. So it's the advantage of prediction in this. We use and we got this multi-SARMA for both urban and rural time series. As I said, we have more detail on seasonal behavior due to the greater use of information in multivariate than univariate, because in multivariate we use two time series and two correlation, not just one autoregressive or moving average. We saw adequate conformity and performance of multivariate models that was acceptable. We used a Dickey-Fuller test to examine stationary in the mean at a 5% level of significant. We saw uncorrelation and Zin-Miro, which are the assumption for accepting white noise. The result of legend blocks confirmed the uncorrelation, and zero mean and the stationary variance of residual were also observed in the plots. The results showed the significant time lag cross correlation. I mean, we have time lag cross correlation between rural and urban mortality time series in Iran. So one of the logic reasons for this statistical analysis is holidays trips, such as, for example, this is one of the logical reasons, such as New Year's or summer vacations. In these days, I mean these vacations and holidays, the volume of rural the roads increases, and vice versa happened. The volume of urban roads also decreased. After the holidays, the volume of rural roads decreased relatively, and the volume of urban roads increases. So this is one of the logics. These are our references, and thank you so much for hearing me.
Great, thanks, Milad.
I am now open for any questions. Thank you so much.
Perfect. Any questions for Milad? Please put them in the chat window.
Okay.
We're still doing pretty well on time.
Thank you so much. I'm here to see your questions.
So there's a question from Ellie about the data set size.
Yeah. As I said about our data in data collection, let me just take a look at this time series. We have 142 points. I mean, these are our points in time series. In time series, we have a lot of references that say, okay, if you have at least 90 points in time series, so it's enough to model that time series. But our time series, and if you look at this time series, is between 2005 to 2016.
Any other questions? All right, if there are no other questions, thanks Milad for your presentation.
Thank you so much.
Thank you. Move on to the next presenter, who is Trey Hahn from the University of Amsterdam. I see Trey, you are online. I just unmuted you.
All right, hello.
So hopefully you can share your screen.
All right.
And get started.
All right, can everyone see that?
Yeah, it looks great.
All right, so this presentation's qualitative research, so there's no modeling involved, but hopefully you guys still find it interesting. So collaboration, experimentation, continuous improvement. So this is looking at a more iterative way of working and the municipality of Amsterdam's Spatial program specifically. So to start, I have some quotations to just get thinking about the context. So scholars can think of what is the role of the planner. Boland thinks it's to help the community become a better place. Campbell, Tate, and Watkins say planning is an idea made up of concepts and sets of practices which aspire to change the world for the better. Now, with this in mind, how do transportation planners do that? Is the question. And this research looked at a formal way to do that, which is public planning organizations. And within this, we chose one organization to look at and see how it works. So these are some key ideas we have in this research: experimentation, learning, knowledge, and iteration. So these are all connected, and you'll see that they come up throughout the presentation, but I wanted to introduce them now. So people may be familiar with the wicked problems that were brought up a few decades ago. And essentially, some recent scholars thought that planning challenges, since they are more complex, are very well suited towards an iterative way of working. So this research wanted to look at this in detail a bit more and see if it makes sense. All right, but is this way of working possible in a public planning organization? Sometimes people think of municipalities, of governments as bureaucratic, of an environment not very well suited for a more iterative way of working. So we wanted to check out if this was actually possible. And if it is possible, is it bringing any benefits? So how did we operationalize these concepts? So we used an agile way of working as this iterative collaborative way of working. And we did this because there's extensive literature on an agile way of working. Here you have the characteristics and the practices. And we developed these from literature. However, we don't have a lot of literature on an agile way of working in transportation planning. So we had to adapt some of these from the IT context and from the project management context. So some of these key ideas include focusing on people and interactions over processes, being responsive, focusing on satisfying the customer, having more self-organizing teams, as well as continuous testing and improvement, having the manager be a facilitator, maintaining a constant work pace. And these characteristics and practices we showed throughout our research with the interviewees as well. So now we have the idea of what this agile way of working is. We had to figure out how this would actually happen in a public planning organization. And we used this multi-level perspective from Gales, and I will explain this briefly. So essentially, and I hope you can see this cursor here. So the landscape is the top level. The regimes and the niches lie below the landscape. But the landscape is it's the external environmental factors of what's happening overall on a very high level. And this landscape influences everything else. Below it lies the regimes. So the regimes both influence and are shaped by the landscape. And the regimes also influence what is happening in the niches below them. And the niches are where the ideas start. So this can be basically, this can explain that in the niches here, at the bottom, you will see that's where we're predicting the agile way of working is. There are ideas that are out there, but the regime is currently working in not this sort of way. So we brought this multi-level perspective to develop research sub-questions and make conceptual steps on to how we're going to explore these ideas. So the first one was to see if this agile way of working is detectable by the existing transportation planning regime. And our sub-question with this was, how accessible and relatable is it to planning departments? The next step would be to understand the context of the planning department. And the reason for this is to see the, it's working, okay. Yes, hopefully the mouse is working. To see the difference between the current way of working, which would be here in the regime level, and the agile way of working down here. All right, and the final step is to learn about the barriers that need to be overcome in order for this way of working to rise up into the regime. So that question was, under what conditions might agile be adopted by planning departments in practice? And for this last part of our research, the third research sub-question, we needed to operationalize barriers to an agile way of working. So we have these here. And again, these are also developed from primarily project management and IT literature, since there's less that specifically exists on the planning context. But you can see some of these typical barriers include management style, having a shared understanding of an agile way of working within the team, bad perceptions of an agile methodology, the organizational structure, etc. Okay, so moving on now to the research design. So how did we investigate these ideas? In short, we used interviews. So we looked at this way of working in one public planning organization through the lens of the staff. So we weren't directly observing these people working. We talked to them to hear how they perceived their own organization. So we had two sets of interviews. We had 12 semi-structured interviews. This was on the organization in general. And then we had 2 narrative interview and process mapping sessions. We combined the narrative interviews with a more visual mapping session. These were focused more on specific projects within the municipality, which leads us to the case study. So the case study was the municipality of Amsterdam. Here you can see a map of the center of Amsterdam, and we focused on one project, the Alexanderplein project. So in the narrative interviews, we targeted this project, which we'll explain soon. Yes, in short, this project was, you can see here, the municipality had an experiment where they turned off the traffic lights to see if they could improve traffic flow at the intersection. And this was quite a radical idea, and their stakeholders were they were not all on board immediately. So it took quite a bit of time to get people on board, and it was an experiment, which makes it quite an interesting case study for this research to see how this experimental way of working, this more iterative way of working is happening. So looking at the semi-structured interviews, we made an item list from the conceptual steps presented earlier. And we also wanted to see how these practitioners perceived project success and if they identified any potential benefits or disadvantages from the way they were working. So the list we brought out in the beginning, those practices, characteristics of an agile organization, and then also the barriers to having this sort of organization. We got these practitioners to give a very open-ended feedback on these lists. And from there, we did thematic analysis to look for key themes. And here you can see the people that we talked to. So we tried to talk to a variety of people in order to get a broader perspective. And because there are a lot of different stakeholders in an organization, and they'll have their own function specialty, we got people from across planning, program, project management, urban design, community engagement, policy. Okay, and the second part of the interviews were the narrative interview and process mapping sessions. And this, again, was a hybrid session where we heard people's personal experiences about the project. The narrative interview essentially is it's a one question, open-ended interview where we ask them, what were your perceptions of this project? And we let them tell the story from there. And the process mapping is constructing a model that shows the relationships between these different stakeholders, or the activities, people, data, objects, etc. So we did thematic analysis on the narrative interviews, and the process mapping sessions also got the interviewees thinking a bit, and it made them also tell us more about the different stakeholders involved in the project. So what did we find? In short, we found that this way of working is partially happening in the bicycle program of the municipality of Amsterdam, and it's bringing benefits. We did find some nuances to this though. And here you can see partially happening, and you will see why that means. So first, looking at the findings on the organization in general. First, we included some quotations here just to give an idea of what people actually said about this agile way of working. And since this is not a tech company, not everyone knew what an agile way of working was, but when people were shown the principles, the characteristics and practices behind this way of working, they were able to identify with them much easier. And there's, so let's go through a few interesting quotes. So one was on satisfying the customer. So the customer is very wide. Who is the customer? You are a different customer than I am. And people in other branches over there, we are all different customers. So essentially, when you're translating these ideas from the IT context where it's more clear what an agile way of working is, we have to interpret and make new, in this case, it was very good to talk to practitioners to see what they thought the customer is, because there are different perceptions. When you're a transportation planner or a designer or project manager, who are you serving? There are different types of people. All right, the next thing, we will look at some more quotes from the agile practices. So for example, we can look at reflection. So one person said, if you start with the project, you have to think of what you want. What was happening before? And make an analysis, of course. Are we solving the problems, or are we solving? We have to reflect on what we do and base our work on the analysis of things we want to change. So essentially, in order to have an effective project, reflection does seem to be an important component of the way of working. So we made a thematic map trying to distill all these different interviews into some key themes. And we had 4 main themes here. One was there was a lot of need to balance interests and different stakeholders. Things like citizen involvement, political priorities, people being emotional when workers have to deal with each other. There's internal politics you have to deal with, etc. Stakeholder dependency, multiple goals and visions. And there are also other challenging conditions as well, such as limited time, limited money, limited capacity, and also numerous changes going on in society at large that they claim are affecting their work as well. And we found that the manager plays a key role in addressing these things. The manager sometimes can act as an enabler, or sometimes chooses not to act as an enabler and chooses to control things. There were different perceptions between practitioners on what they thought the role of the manager should be. Top management support is also a key part of this. And we found that collaboration is a solution for some of these challenges. And it enables you to balance interests and stakeholders more. In the case of the Alexanderplan project, where they turned off the traffic lights in an experiment, this was key as well. It was able to help them navigate a larger bureaucracy with all these different stakeholders And without the collaboration, they would have been stuck, essentially. So some of these other, this other sub-themes here, see smaller working groups, feedback, working across departments and disciplines. These were things that were brought up during the interviews. So going back to the main research questions now, is this organization working in an agile way? And we found that overall, yes. And here you see we have the operationalized list of agile characteristics. And you can see if anyone is interested in this and they want to see the full paper, I will show my email at the end, and you can see this in more detail. But here we break down for each for each characteristic, how did the bicycle program in the municipality do this? So for example, let's see. Yeah, so for information drives decisions, not a work hierarchy. This one was an important characteristic, and it was brought up consistently. So from the interviews, we decided that they were working in this sort of way. Information was driving decisions more than their internal work hierarchy. And the only thing that we decided was red in this case was responding to and welcoming change. And we found that while some individuals and small working groups do this, overall, the municipality appears to struggle with it. Overall, the organization does not respond to change as well. Moving on to practices, we found overall that the group is working in this sort of way with these practices. One thing that was actually inspiring during doing these interviews was that practitioners were very reflective, and they thought about their own role, they thought about their organization's role. So we found that there was a good amount of reflection there. There was not so much early and incremental delivery of their working product. And given that this can be interpreted in different ways, and they did often give feedback, they tried to get feedback on ideas, but there was not any sort of delivery of these things continuously. And that may potentially have been beneficial to depending on your perspective, to deliver a public product, so maybe a community meeting or a conceptual design of a corridor early in the process so they can improve on it from there. The other thing that the group struggled with was simplification. And what this means essentially is you're only spending time on things that deliver value. Now, the first thing you have to decide here is what delivers value, and that's a good question. But essentially, the workers decided that they're spending a lot of time on things they didn't feel like were necessary. For example, meetings, emails. Sometimes they felt like they weren't necessarily, they weren't using their time in a way that was benefiting people directly. Moving on to the findings of the Alexander Plan project. So this was the project where they turned off the traffic lights. And in order to do this, they had to consult many different stakeholders. So one of the main themes we saw in these interviews was that of maneuvering stakeholders in the organization. The municipality of Amsterdam is, on a global scale, it's not huge, but it's, especially on the Dutch scale, it's the largest municipality here. And there are lots of employees. Yes, the cities are close to 1 million people now. And I believe there's several thousand people in the municipality. So this was something significant for them. And within that, professional relationships, administration, stakeholder needs, dependency, and the amount of people were sub-themes. We found this theme was also very connected to 2 other themes. The iterative project strategy helped to maneuver these stakeholders and the organization. And it was also connected to the legitimization of decisions through analysis. When they did this trial, when they turned off the traffic lights, they concurrently had 2 research studies going on. They had the university do a qualitative study where they interviewed people going through the intersection. They asked how they perceived the intersection before this change, how they perceived it with this change. And they also did a quantitative analysis, a more traffic-oriented analysis to see if there were conflicts happening without the traffic lights on. And to clarify, this intersection was primarily used by people riding bikes. The traffic volumes for motor vehicles were much lower. There were trams as well and people walking, but the primary use of this corridor was the bike, which is why it's easier to turn off the traffic lights. I think if you had, it would not be the same thing if you had mostly motor vehicles in this intersection. So we found these three things really feed off each other, and they made this intervention possible. Through talking to people had decided that they absolutely hated the intersection before the intervention, and they hated it significantly less after the intervention, mainly because their waiting times no longer existed at traffic lights. Before, there were queues of people on bikes trying to get across the intersection for red light. There were no longer queues backed up for a while during these busy periods. However, it did make people need to interact more with each other in the intersection. And it's, yes, when you turn off the traffic lights, there's no longer, you have to make your own social rules when moving through. So you need things like eye contact, you need to look at bodily cues, and everyone's speed is also significantly slower. We also asked the interviewees for this part to draw some process maps. And essentially this is trying to map out visually what happened in this intervention, who were the different stakeholders involved, and what were the pain and the positive points here. We don't have time to go into this here, but if you're curious to what people drew, you can look in the paper. Was this project agile? We found, yes, definitely. The amount of interviews we had, since we only had 2 more detailed sessions for this one, with someone from within the municipality and someone from outside the municipality, we were not able to determine every single characteristic in practice. You can see there are some that are still blank, but we found overall that they're definitely working in this project. So it's quite almost unexpected a bit. This is so, yes, such an agile way of working. And the practices are similar with the exception of simplification. And so in theory, this is a somewhat simple intervention. It's turning off the traffic lights, you flip the switch. But in order to do this, there was a lot of interaction with different stakeholders that had to happen. It was not just something where it was supposed to be a low cost intervention, but because of the time commitment that the staff had to put into coordinating this, that ended up costing more. So wrapping this up, the traditional goal of optimization and control is making way for learning and innovation. So essentially, when it comes to the way of working, these people are saying that through working, you can learn and you can innovate. And we found that this is possible with the Municipality of Amsterdam's bicycle program. And this intervention at Alexanderplein, where they turned off the traffic lights, was a way for them to learn just as much about improving traffic flow at the intersection. They were then subsequently able to apply some of these concepts and some of this practical experience that was publicly viewable for everyone to different intersections throughout the city. For example, at Muntplein, another intersection in the center, they rerouted traffic patterns and they also removed the traffic lights. So by doing this in the physical realm, they experimented, they gained knowledge, and they also gained organizational capacity, organizational knowledge. So conclusions are that this way of working is possible in a public planning organization. Amsterdam may have been a part of the reason it was a case study is because we had reasons why we suspected it was working this way, and not every organization may be working this way. And we found that people attempting to foster this way of working should be cautious not to force a specific methodology. If anyone is familiar with Scrum, it's an example of a methodology where it's very prescriptive it tells you, here's what you have to do step by step in order to work in this agile way. That's an example of something that can, if you push something like that too far, it can ironically be perceived as it no longer can be agile because it's no longer flexible. It's no longer reflective. It becomes very rigid for some reason. And we found that the bicycle program is already partially working in this way, and even only partial working in this way is bringing benefits. So it's not necessarily an all or nothing affair. People can get benefits from doing some of these things. Maybe not all the principles that are used in other contexts are 100% relevant or possible, but some can be. So what are some takeaways for practitioners? These are a little bit conceptual, and you have to interpret them yourselves, but here we go. So understand your own working context and look for opportunities to intervene there. Thinking about your way of working, every place is unique, and people that work inside it have a unique view into it. So as a person inside it, you know where you can intervene potentially. The next is consider your people. If you are working on the organizational side or the human resources side, selecting people that work in a way that tolerates risk-taking, that is okay with collaboration, does make a difference. One interviewee said that they did not think that it was possible for every single person to work in this way, but certain people on their team were able to do this and were able to reach out to people in different departments, were able to try out these new ideas that made the project possible. And the last is to keep the focus on principles and goals, meaning the end goal of this is not to be certified agile. Sometimes this is a word that can have a lot of different meanings associated with it, and it can be distracting to focus on these buzzwords. Instead, it should be the focus, especially if the people do not identify with these words, the practitioners do not appreciate them. The focus is really on growing and learning as an organization, and going back to the purpose of planning in the first place, is it serving the citizens and communicating this? If anyone's been part of a Scrum team or an Agile team, I can imagine maybe you may have noticed that there becomes a lot of jargon. It becomes very focused around these words and these, that can feel like a bit of a cult sometimes, which ironically is not what these principles are. So it's when you're communicating to your team, it's important that you keep focused on the principles and the goals. Thinking about limitations of this research and what comes next. This research focused only on Amsterdam practitioners. And because we had reasons why we chose this place, because it was already, from our experience working partially in this way, it was good to research, but it'd also be good to see what it's like in different contexts. And now that we know this way of working is possible in a public planning organization, the next question is, how does this happen? How do we enable this? How do we implement this? And future research for this could critically explore and compare different agile methodologies, or it could also look at the developments of a new one for the planning context specifically. And finally, this was a largely agile project that the research focused on. It could be interesting to conduct a comparative analysis with the project that is agile and one that is not, in order to see the different outcomes between the two projects. All right, and this is the last main slide. And after this, for whoever has ideas or thoughts, it would be great to get your feedback on this research. Part of the reason why we're bringing this to the conference is to get people's thoughts on it. So in addition to any questions, any conceptual, theoretical, or methodological feedback would be much appreciated. So essentially here, this flowchart is experimentation leads to learning, leads to knowledge, leads to iteration, leads to reflection, leads to more experimentation. And this loop can continue. And essentially, these ideas that comprise this iterative, collaborative way of working, they work together. And as you can see here, this is a cycle that can continue. And if this feedback loop is flowing, in theory, organizations can learn, they can grow, and they can, in the end, better serve their citizens potentially. And that's what we begun to explore in this research. Yes, so that's basically it. I had some, if we have, depending on how much time we have, I was curious to get your feedback on these sort of things. And then if you are interested in this, send me an email. I will send you the full paper. I'm happy to talk about it. It's very interesting for me. All right, thank you.
Thanks, Trey. Are there any questions, comments for Trey? Please type them into the chat window if you have some. I can kick off with one question. I was curious about some of the diagrams you showed summarizing the results of the interviews.
Yeah.
Can you just talk a little bit about the methods that you use to arrive at those themes and put those diagrams together?
Yeah, very good question. So we had the interviews, we transcribed them, and then we did qualitative coding. So we did it in, I think this one we did in, not in vivo, we did it in, oh gosh, it's been a little while since I did this. Yes, we did, qualitative coding software. And from there, we just did several rounds of coding, and we determined, we had several themes, like a long list, and then we kind of grouped things together. They became smaller and smaller, and so we had those 4 main themes.
The coding process, is it very collaborative? Like, can you just, I'm curious to get some more detail about how that actually
happened. The coding process was not very collaborative. The coding process was mainly me, just doing several iterations of trying to see, like, where did things kind of converge. I think it could be, that's interesting if it would be more collaborative between, I think you get different perspectives with more people coding.
Yeah, and did you find the software to be helpful for that? I'm always curious about what the benefits of using qualitative coding software are as compared to just kind of sitting with the primary sources and trying to extract insights on your own. So if you could speak to some of the benefits of the software?
Yeah, good question. So and I just checked. So we did an Atlas TI, and we did find that, so it was free because the university has access to it. I thought, why not? I also looked at doing it manually with Word and Excel, because really this is not like rocket science qualitative coding. You're just going through text, you're identifying things that are repetitive. I did find that it was helpful in keeping things organized, I think. I previously used NVivo, which is another qualitative coding software, and this was my first time using Atlas TI. So I was still getting used to the software a bit during the coding process.
Got it. Thanks. Did you find much difference between NVivo and Atlas TI? Any reasons to prefer one over the other? This is a selfish question.
Yeah. No, not in particular. I mainly use Atlas TI because that was what we had available at the university.
Got it. Cool. Any other questions for Trey before we transition? Okay, well, thanks very much, Trey.
All right, thank you.
Thanks. Okay, so next we'll have Matt Wigginton Conway from Arizona State University. So Matt, I'm going to unmute you. And then hopefully you can share your screen.
So I'm actually not giving the presentation. Laura Murtich will be starting out, and then she'll hand it off to Nathan Harness.
Okay, great. Okay, so Laura, you've been unmuted. Maybe.
Yeah, Laura. I'm all unmuted now.
Okay, great. So you're going to switch over and you're going to pass off to Nathan at some point?
Yes, correct. He'll be doing the second half of the presentation, but we'll both be back for questions.
Got it. Okay, great. So you can go ahead and share your screen and get started.
All right. Thank you very much. All right, good afternoon, everybody. My name is Laura Murtick. I'm a student at Arizona State University working in the Salon Lab, which is in the School of Geographical Sciences and Urban Planning at the school. I'm going to be presenting today, as mentioned, with Nathan Harness, And today we're going to be talking about the importance of attitudes in travel behavior models. This is a forthcoming literature review that our lab is working on. So a really essential question that we must ask at the beginning is, what are attitudes in this body of literature? So we measure attitudes in a number of ways in the papers that we've come across. First, we might mention attitudes through perceptions. For instance, a respondent to a survey who says that there are many bike lanes easy to access in their neighborhood would be displaying attitudes by their perceptions. Attitudes can also take the form of beliefs. For instance, someone who says that people need to walk or cycle more to reduce global warming would be showing attitudes through a belief like that. Third, lifestyle attributes. For instance, an individual who reports enjoying spending most of their life working would be showing attitudes through their lifestyle. And finally, attitudes can take the form of a preference. For instance, someone who said that their ideal neighborhood is a high-density urban center would be displaying a preference. So then, looking at these attitudes, we're going to get an overall picture of how they're included in the literature. In an effort to better inform transport policy workers, a large number of studies have begun to incorporate attitudes as explanatory variables in their models of travel behavior. And most, but not all of the papers that do this find an association between attitudes and the transport choices that somebody makes. Of course, when we discuss this trend, it's important to note that positive findings may be more likely to be published. So while we see this strong association in the literature, it may be somewhat inflated by a bias in published studies. However, one thing that's important to note is many of these studies that do find that association between attitudes and the transport choices of individuals also find that the predictive power of models increases when attitudinal information is included. However, there is a rather unfortunate trend where the only way you can really isolate the effect of attitudes in a model is by taking two identical models of travel behavior and then just adding attitudes to one. So all other explanatory variables remain the same. However, it's rather unfortunate that most studies don't make this explicit comparison. So we can't for sure look at that isolated predictive power of the attitudes in the model in most situations. So the main research questions that we're looking at in our literature review is based on what we read. We're first wondering how much attitudinal variables improve the predictive power of travel behavior models. Second, we're looking at which attitudes are most important to help explain that travel behavior. And then third, when we look at specific populations, for instance, people of different age groups or people in different countries, or when we look at different transportation-related choices, we want to know if the attitudes that are most important to explain behavior are altered or changed at all. So this project was born out of the TOMNet Center. The TOMNet Center stands for Teaching Old Models New Tricks, and they are motivated because current modeling and practice largely does not use attitudes, which is kind of a difference between academia and policy right now. And this sort of motivates the center's research. So they're looking to improve the models that we use to look at travel behavior by incorporating attitudes. And as a step in this process, our group has undertaken this broad literature review of the papers published on the subject. So we had a number of criteria that we used to include studies in our project. So first, we required that the words attitudes, beliefs, or perceptions be mentioned in the title, abstract, or keywords. And this was just to maintain relevancy to our particular research questions. We also required that the papers included either a factor analysis or a principal component analysis. So many studies may not include this factor analysis or this PCA step. The reason why we felt that it was better to include it and why we only read papers that had a factor analysis is because if a researcher chooses to put only raw questions from the survey into their model, those questions are more indicators of attitudes, but they don't represent the attitudes themselves because attitudes are kind of latent and intangible, and you can't just get them straight from a survey. And we felt that a factor analysis allowed us to more directly input an attitude into a model. So here we have examples of some of the transport keywords that we searched for to get papers. This is just showing what was relevant to the literature review and the topics that we were looking at, such as mode choice, someone's residential location, or various travel outcomes like vehicle miles traveled or vehicle kilometers traveled. So this can just give you a sense of the set of papers that we were looking at for our project and what was most relevant to our literature review. And then finally, we had some additional criteria for what papers were selected for the literature review. So we had hundreds and hundreds of articles come up from those searches that we showed, and these criteria were used to pare down that group into a much smaller number. So first, we required that the sample size in the paper was either 300 individuals or greater. This was just important for making sure the results were robust and credible. Second, we required that the analysis had at least 2 sociodemographic controls in the model, such as age and income, for instance. The reason that we did this is because currently transport models in use in policy already tend to control for sociodemographics. And so what we're really looking at is, are attitudes going to improve what we already are doing? So we want to make sure that baseline of having sociodemographic controls there so that the model was similar to a model that might be in use today. And finally, we did not allow papers into the literature review that were about long distance travel, evacuation, AVs, or children's travel. And this was just because these 4 examples are rather unusual contexts where there are likely many other factors playing into somebody's travel behavior. So the findings from a paper in one of those situations may have not been super applicable to another situation just because of the unusual context. So the sort of generic structure for a paper that was included in our literature review generally had 3 parts. First, the researchers would have distributed a survey instrument where participants were asked a number of questions on a Likert scale. So an example of a Likert scale is shown below. It's where someone is given a statement or a question and they're asked to give a ranking from strongly disagree to strongly agree, for instance, or ranking from 1 to 5 or anything like that. So they would gather this quantitative data from these Likert scales. Then they would factor analyze the responses. So this large list of questions, such as those you see at the left side of the image below, would then be condensed into a smaller number of factors that were supposed to represent the attitudes of the respondent. And then those factors would be put into the model of travel behavior as an explanatory variable. So one of our big findings that we found is that the majority of transportation models that we reviewed had at least one statistically significant attitudinal variable. So at least in one way or another, people's attitudes were affecting their travel behavior according to the models in most papers. Again, like I mentioned earlier, the papers that are really most interesting are those that make a direct comparison between 2 models, which are identical except for the inclusion of attitudes in one model, but all other explanatory variables remain the same. Like we said, this was unfortunately a fairly small group. You can see the papers listed below, but it is notable that within this group, every single paper that made that explicit comparison found that attitudinal data improved the models. And then before we dive into some of the more specific attitudes used in the literature, which Nathan is going to go ahead and cover, we want to note an important obstacle. So there is not much consistency across studies in this body of literature. Even if 2 different surveys are trying to measure a similar attitude, the questions they might use to do it are often extremely different. Secondly, even when there are 2 studies that are looking for the same outcome of interest, for instance, predicting vehicle miles traveled, they might look at very different attitudes to explain that. And then there's also some variation in why researchers include attitudes in their models. So most researchers include attitudes because they are trying to improve the predictive power of their models, but there are also a number of researchers who use attitudes in their models to control for residential self-selection, which is an interesting trend that Nathan's going to go into a little bit later, wherein people choose to live in neighborhoods that reflect their transport preferences. And so including attitudes sort of serves as a control for this uneven sorting of people into different neighborhoods. So we just want to note that one of the biggest things we came across in literature was this really wide variety in how these surveys are conducted and why. And with that, I'm going to go ahead and mute myself and turn it over to Nathan.
Okay, I'll handle that transition.
Hello, I am Nathan Harness. I'm a undergraduate researcher at Arizona State University, and I've also been working at the Salon Lab on this project for quite a while now. Everybody can hear me just fine, right?
Yeah, you're good.
All right, perfect. Okay, not sure why that happened, but there we go. So to illustrate that lack of heterogeneity, of homogeneity that Laura
and Nathan,
mentioned,
your Zoom windows are covering your slides.
Oh,
you can minimize or drag those away.
Yeah, thank you so much. We categorized all of the questions that we received during this literature review in over 60 papers, and we found over 40 broad categories of questions regarding attitudes. So there's a wide variety of attitudes that are being measured in this literature, and we frankly don't have the time to go over all of them. So we have a small subset here, and we're going to go into 4 of those in this presentation and talk about the type of effects that we saw in those and the type of novel findings that we had for each of those attitudinal categories. So the most common attitudinal category that was measured in the literature in this field was mode liking, the extent to which people felt that they enjoyed or preferred to use a specific type of transportation mode. And somewhat predictably, we found that in most cases, enjoying a specific type of transportation mode statistically increased your likelihood to use that transportation mode. We also found that this particular question was most common and most significant in bicycle commuters, and that for bicyclists, the extent to which they prefer to bicycle vastly increased the extent to which they do bicycle much higher than for other transportation modes that people might like to use. Now, Laura talked about the factors of residential preferences in her section, but we found here that a large amount of this research was focused on using residential preferences to identify the extent to which the built environment affects transportation mode usage. And in these attitudinal questions, they are attempting to control for the actual reasons why people live in places to identify the extent to which the built environment actually affects the people's mode choices. We found 2 broad categories of residential questions, which were just where you prefer to live and your perceptions of the places where you do actually live. So most of this body of literature is focused on residential self-selection, which is how people's tendency to choose to live in places that align with their own transportation needs or desires affects their actual transportation usage. So by far the most useful type of study in this space was dissonance studies, which compare individuals who prefer to live in the place where they do live with individuals who would prefer to live somewhere unlike the places where they do live. And in those studies, we found that in almost all cases, both the actual built environment where people live and the place where people desire to live have independent effects or independent correlations with their travel behavior. So neither travel behavior cannot be directly predicted either by just where people live and the actual effects of where people live, or by where people prefer to live. Another broad category was the people's perceptions and preferences regarding safety. In this space, we found there were two general types of safety that was being measured, which was personal safety from crime or other people, and physical safety of the mode itself. This one was, again, particularly extensive in cycling, because that's a more exposed form of transportation. And again, this was a particularly difficult category of attitudes for us to identify the independent of effect of, because safety questions often load onto factors that categorize an entire mode. So this bicycle safety question here that we have as an example would factor into a mode, into this particular one factored onto the factor of just desire to use active transportation. So it was difficult for us to identify the extent to which safety needs independently affect the mode choices that people make, and we recommend that there is more study into that particular effect and that particular attitude. Another area with a bit of limited research was the effect of social norm and its correlations with transportation attitudes and transportation usage. So we found that in places where social norm was measured and did find to have a significant effect, that usually people chose to align with the expected social norm of their communities. People who found that the people around them often took transit or bicycled, often themselves used transit more and bicycled more. We also, however, a lot of the papers on this topic are on the theory of expect the theory of planned behavior as a structure for their investigations, and most theory of planned behavior documents or studies that were in the literature were excluded from this review for a lack of sociodemographic controls. So we recommend that more research into the effect of social norm on transportation behavior and the correlations there is performed with sociodemographic controls that we didn't find in most theory of planned behavior documents. So we found that throughout this research review that the methodologies used in this field were not necessarily ideal for the purpose of generally reviewing the effects of attitudinal factors on transportation behavior and the correlations there. So a big part of that is that often authors would not include sociodemographic controls because of difficulty in collecting that data in certain places and the like. And this makes it really hard to identify whether the attitudes that they did measure actually improve their models, or if the attitudes are just a stand-in for the sociodemographic variables that they didn't measure. We also found that when papers didn't include all of the data that they collected in their models, it made it more difficult for us to identify the extent of the significance of attitudinal factors. And using stepwise regression or removing insignificant variables from your models is going to inflate the significance of the remaining variables, which can make it seem like those factors have more of an effect than they actually do. Again, the attitudinal questions that are available to us in different studies are very vastly different throughout the literature, and it was difficult for us to synthesize those into a specific set of conclusions that we could make. that is an ongoing process that we are doing in this review, but it is challenging. Again, the most useful tool that we had during this review by far was, as Laura said, the papers that directly compared models that include attitudes with models that do not. And we found that papers that don't do that were much less useful for identifying the actual extent of attitudinal variables' significance effects than papers that did. So with those challenges in mind, we have some recommendations for future research in this area. There is a couple of gaps in the literature that we've reviewed so far that we would recommend some researchers fill over the next, in this literature. First off, we didn't find a very large body of research over how individual travel behavior changes over time as their attitudes or their built environment changes. So longitudinal studies of populations would be very helpful for this research in this area. Again, more dissonant studies, which have been very helpful in identifying the specific effects of attitudes and the specific effects of the built environment, are necessary to increase the body of literature that we have on that subject. And methodologically, we have some recommendations for future research in this topic as well. We highly recommend that researchers retain all the variables and all the data that they collect in their models, because this allows us to directly measure the significance of the variables of every variable that they include. We also recommend that researchers adopt a standardized battery of attitudinal questions, which will allow us to directly compare between different areas and different subjects, which will allow it to be much easier for us to identify trends in attitudinal factors and the effects thereof. We are developing a standardized questionnaire during this review and during the actual publication of our paper that will be included. We also highly recommend that researchers in this subject directly compare models with and without attitudes. This allows us to directly measure the change in predictive power that we see when we include attitudes in our model. And this will allow us to much better measure the value that including attitudes in our model provides to metropolitan planning organizations. So as part of this project, we've created a public database of every research paper that we've reviewed over the last couple of months. This will be available to the public upon our publication, or possibly sooner. I'm not actually sure what our plan is for that right now, but it's extensive, and we have over 60 papers in here. In every model in every paper that we've reviewed is viewable in this standardized sort of location. So we hope that this will be helpful for future research and future study into this particular subject and this particular area of transportation planning. Here's our references, and if anybody has any questions, we will be taking them now. Let me see if I can find.
Thanks, Laura and Nathan. Okay, if folks have questions, please type them into the chat box. And I'll unmute both Laura and Nathan so y'all can decide how you'd like to respond.
If you could unmute Conway as well, that would be helpful.
Sure.
So for which attitudinal factors we found were most useful in improving accuracy, we did find that there was significance in almost all attitudes. Like every category has at least some areas where we did find increases in significance and significant factors, but I think that if, and I think Matthew or Laura may disagree with me on this, but I think that just including mode liking increases the predictive power of models significantly and is a somewhat easy means of achieving that.
I'd agree with that, yeah.
Yeah, it definitely that mode liking attitude had a big effect. I think also one thing that's important though is depending on the outcome variable or the group that was surveyed, we really saw just wide variation in what attitudes were most important. For instance, the attitudes that might have the greatest predictive power for someone's chance of buying a car in the next couple of years might be a totally different set of attitudes than what best explains someone's likelihood of using the bus, for instance. So there's, I definitely agree with what Nathan and Matt are saying, but I would qualify that with, it's hard to get just the one like golden attitude that is the best explanation for everything.
Yeah, I think that's fair. So I believe we have used hybrid choice models. We have looked at that. Is that correct? I don't remember exactly. I don't remember every paper that we've read, to be honest.
I believe, oh, sorry, Matt. I believe we do have some hybrid choice models in the literature that we read.
Here's our main database. So at some point, you'll be able to look through this and identify exactly which models each of these papers used. We did include the type of model that's used in here, and I'm sure that there's, and so like eventually you'll be able to search through this and see what type of models people use and how people use them.
Yeah, I guess just to hop on that, we did read a number of papers about that. They do usually come up because usually there is a factor analysis that happens, either the confirmatory factor analysis that happens as part of that choice model, or a exploratory factor analysis that happens beforehand to kind of create the inputs to that. So there are a number of papers in there that use that that approach.
Any other questions for the presenters? Okay, thanks all for your presentation. And we'll move on to the final paper. It's going to be presented by our co-host, Irannezhad.
All right, thanks guys.
Thank you.
Hi everyone, this is Ellie from Australia, Brisbane. It's almost 5 a.m. so I apologize if I fell asleep. No, I'm just kidding. I'm very awake. Well, let me just for a couple of minutes sincerely thank everyone, including the others, reviewers, co-organizers, Alex. Thanks to you for moderating this track. It was a real pleasure working and connecting with all of you, and I really hope that this kind of conference continues in the next years as well. Let me just tell you the story that when it all started from a telephone chat that I had with Cara in September, when she asked me if I have a plan going to TRB this year. And I raised this issue that, well, first of all, I need visa, and because of my nationality, that I'm from Iran, it's a bit difficult. Then I need securing some grants to support my travel. And also it's too much hassle traveling to US from Australia for me personally. So, and I was saying that, well, it would be very fantastic if TRB can play the recorded voice or a presentation of mine. And also, when I said this to Cara, Cara also loved the idea, given that she's apparently, she always feels guilty about the carbon footprint of her travel. So yeah, it triggered from just that telephone chat, and then we decided to announce it and advertise it on the web and got some volunteers. And thanks to every one of you who submitted your paper or reviewed the papers, and thanks to also our tech guy Krishnan who designed the website, the backup team Vahid and Vento who helped a lot in sending some emails. And I apologize if we flooded your mailbox with lots of emails during recent days, but I think that it will be more organized in the future years, and hopefully it continues. Okay, so yeah, let me just start my presentation. So what I'm going to present is a study that my student Hamid Rezai did for his master thesis from Tarbiyat Madaris University, Tehran, Iran. Is modal choice behavioral response to hourly based congestion pricing. And I was his co-advisor, thanks to also his main supervisor, Dr. Mamdouhi. I remotely co-advised this thesis, and unfortunately Hamid is on compulsory military service now, so he didn't have access to internet to present, so I'm just presenting on behalf of him. Okay, let's start. So just a bit of background. Tehran is the capital city of Iran. You all heard the name of it. It has about 8 million residents and about 13 million daytime population. It covers about 700 square kilometer. And Tehran's congestion charging scheme is in place since 1979. So it's about 39 years, or actually 40 years that we have congestion charging in place in Tehran. And the aim was to reduce the use of private vehicles and air pollution. This scheme was controlled manually first, but now it has been controlled by automatic ANPR cameras, I think since 10 years ago. And it's an area-based pricing scheme. It covers 75 square kilometers of the central business district. And this scheme covers a downtown area which mostly consists of traditional bazaars, commercial land uses, and works activity centers with low nighttime residential population, as you can see in the figure. But the daytime activities are very high in this district. According to the Tehran's municipality law, all revenues obtained from congestion pricing must be invested in improving public transportation system. The annual permits are issued just to a percentage of applicants, about like 27% of total applicants, and permits are issued using a ranked-based evaluation system, ranking each applicant based on several items, such as residential address, for instance, if they live inside the congestion zone, their job, number of children, or the number of senior people in their household. So based on that rank, then just about like 27 or 25% of the applicants, they can get the annual permit. The other people who are willing to use this zone, they should either purchase daily permits or weekly permits. And just to give you a background about the price of the permit, the annual permit price is equivalent to 20 days of a blue-collar worker in Iran, and the daily permit price is equivalent to about like 1 day income. Well, as you all know, there are various pricing schemes. It can be categorized in different ways. We can have flat pricing scheme, which is a fixed price. Users just pay a fixed price and then they can enter the zone, or it can be variable based on the duration that they stay in the zone, or based on the entry or exit time. Or it can be responsive, which means pricing varies according to the actual network condition. Or it can be categorized based on time, distance, or only distance-based pricing, which in that case, vehicles is charged based on either the distance traveled or time of day, or combination of both. Or we can have cordon pricing. In that case, vehicles charged every time that passes the cordon. Or we can have zonal pricing, which in that case, drivers can make unlimited trips into and within the zone with a flat or fixed fee. So in Tehran, we have a zonal pricing, which means that drivers who have purchased the permit, they can make unlimited trips into and within the zone on that time frame. For instance, if they have purchased a weekly permit, then in a week, it doesn't matter how many times they enter, the price would be the same. And they're not charged based on the duration, but the entry or exit time, if it's during the peak hour, then is more expensive. And purchasing and charging these prices are the users should download a mobile application, and they should register there, and they should enter their bank account, their credit card information, and then they're charged based on that. So there are some problems with the status quo. The flat area license scheme makes the enforcement easier in such a populated city. However, there are some problems. The flat scheme allows an unlimited number of journeys into and within a zone just for a fixed price. And Tehran has a monocentric urban structure, so there are very important hospitals or activity centers within the zone that it just motivates us to provide more equity for all users, not just a percentage of them. And even though congestion pricing have been running for about 40 years, still there are traffic congestion, air and noise pollution, and delays on that zone. The other problem is, well, daily permit fee is only 50% cheaper than the penalty of entry, which has caused high rate of entries without a permit. Or that's out of scope of this study, but just a background for your interest. It should be noted that the permit fee is 50% cheaper for the residents inside the zone, but still, when we conducted a survey in 2013 among about 1,000 respondents, then 60% of residents preferred to move out from the zone, and about like 49% of retailers believed that they financially were damaged, decreasing the number of customers. So it all motivates city managers to provide a more equitable and more effective scheme that at least they can defend that, okay, we have, there are some drawbacks of this scheme, but at least we could manage traffic congestion and air pollution better. In one hypothetical scenario that we assumed in this study is that users are charged based on the time-based and variable fee according to the duration that they stay within the zone. Well, with regard to the impact of congestion pricing, a few studies that have collected information after the pricing scheme or before that, they have identified that, well, yeah, there are some studies that actually studied before implementing congestion pricing, using SP surveys, and also there are some studies that they have collected information after the pricing scheme using RP survey, and they have identified that pricing policy has been effective in reducing air pollution, congestion. Well, that's very obvious result. And there are also some studies regarding travel behavior, if the users have changed the route or the change of their departure time, how they perceive the scheme. They have either canceled their trip or they shifted the mode of their transport. For instance, this study B had in 2002, they estimated the mixed logic model to model the mode choice in congestion pricing scheme in San Francisco using both SP and RP data. Or the other study by O'Fallon in 2004, they studied mode shift under various policies in New Zealand using SP survey. Or the other study, Zhang, in 2003, they conducted again an SP survey in Netherlands among private car drivers and train users. So you can see that earlier studies have contributed to our understanding of congestion pricing impact on travel behavior and mode choice, yet there remains some unanswered questions. The first question is that how much a revised pricing scheme, for instance, hourly based scheme, can affect the travel behaviors, including modal choices. And how do the effect of pricing in cities differ? We all saw in the literature review that they have done studies in the other cities, but this one is the first study in Tehran that we are developing a mode choice model as a result of a revised pricing scheme. And also there has been little discussion in the literature directed to the examination of hourly based versus flat pricing scheme. The majority of studies have examined the impact of pricing before the implementation phase. And considering that in our study, the participants have a better understanding of the associated costs and benefits of purchasing the permit and using private vehicle, we believe that this research effort in this research is essential and it would be informative. So we conducted a survey. The survey was administered in February 2018 among all different types of travelers. We excluded those respondents who were not the commuter to the zone. And at the end, the full and the complete responses included about 4,000 responses. We asked the survey into 3 sections. The first section covers respondents' travel specification for a typical day, for a typical trip to the congestion pricing zone. The second part is a choice experiment, and the third part, we ask social demographic characteristics of travelers. Here you can see an example of a choice task. The survey was administered manually, and well, unfortunately, the levels were, we had just 3 scenarios. This one is one of the limitations of this study. Unfortunately, after the survey was designed and conducted, I jumped on board. So it was too late to do experimental design for the survey. And also those people who were responsible for designing the survey, they argued that these estimates have already passed the legislation by Tehran municipalities, so we can't change these prices that much. So 3 levels were assumed, or actually were asked for an hourly rate, namely 2,000 tuman, 3,000 tuman, 4,000 tumans, which is actually the charging fee for each hour that the user stays within the zone. Also in this survey, we asked the origin and destination of the typical trip to the pricing zone. So we were able to calculate the travel time and travel distance by each transport mode using the outputs from Tehran's strategic multimodal transport assignment model. So accordingly, these two parameters, travel time and travel distance, are inferred from the secondary data source. Because we believe that, well, actually those who designed the survey believe that if they ask travel time or travel distance, some people may not respond it very accurately. So I also should add that the peak hours in the morning and evening were 6 to 10 a.m. and 4 to 7 p.m. And non-peak hour consists of 10 to 4 p.m. So we developed a Diski choice model based on the econometric theory of random utility maximization. In order to capture the correlation between modes, the panel effect, oh, actually I forgot to explain about the modes that we asked. Here we asked 6 different transport modes: private car, public transport, pooled taxi, which is very common in Tehran. Snap is something very similar to Uber. Actually, Uber can't operate in Iran because of sanctions. So Snap is exactly similar platform. It's an on-demand sharing economic platform, which is again very, very common for commuters. Motorcycle as well, and others which include active transport. So here, in order to capture the correlation between these modes that I mentioned, the panel effect and accounting for heterogeneity, a mixed logit model and a latent class choice model were estimated. About the panel effect, because we had 3 questions in the choice task per each respondents, and we have to capture the correlation given that the respondent for these 3 different scenarios are the same. And the presented random parameter logit model here includes both the random error component and random variables within the model. The random parameters capture the heterogeneity of variables in the population and also accounts for correlation across travel modes, as well as the panel effect that I mentioned. Okay, here I present the results of mixed logit model. It turned out that there's a random taste variation of travelers with respect to some variables. For instance, in a private car, those who have weekly license or based on the gender or occupation, there's a random taste variation regarding these variables and for the other transport modes as well. I should mention that all collected data, travel and social demographic characteristics were tested on a forward stepwise approach, and the significant parameters within 10% of confidence interval remained in the model. And it should also be noted that for every random parameter, various distributions were tested, namely normal distribution, log normal, triangular uniform distribution, SB Johnson. So we tried different type of distribution, and normal distribution yielded better results. All the calculated coefficients are of the expected sign, and relative value, for example, the utility of private car decreases by higher pricing charges, which is very obvious. Well, individuals are encouraged to use private car or Snap in order to reduce their travel time. And also looking at the estimate of the constant, private cars are preferred transport modes for various unobserved reasons that well, we couldn't capture with the data that we asked. It turned out that the utility of private car well, increases with being male and those with bachelor degree. So the current weekly permit users, self-employed people, and the infrequent users to the zone are less likely to use private cars in the revised scheme, while, as I mentioned, those who are male with bachelor degree have a preference towards car. Public transport is still preferred among senior people and those with reported high accessibility to PT, while is less likely preferred among frequent daily travelers to the zone and those with higher degree education. Pool taxi also is preferred for shopping trips and full-time employees, while is less preferred option for trips made at non-peak hours. And the utility of a Snap, as I mentioned, which is very similar to Uber, increases for medical treatment trip purposes and for senior people and infrequent travelers to the zone. But motorcycle is still preferred among single male travelers, while is less likely to be used for education trip purposes and trips ending at non-peak hours. Well, I think these results are very obvious because, I mean, intuitively, because the pool taxi, which is considered as a semi-public transport, provides a faster and more flexible alternative given the lack of parking facilities in the zone. And as you can see here, for instance, full-time employees that they need parking spot in the CBD, but usually there's a lack of parking even for organizations at the workplace. So that's why pool taxi are still preferable for these users. Well, the result that I already presented was the result of the random parameter model, but to understand the subgroup of people, we also estimated a latent class model. We tested different number of classes. We started from 2 and increased it stepwise to 3, 4, 5. And then we compared the goodness of fit by AIC and BIC indicators. And it turned out that 3 classes is the best number. There are some differences between the estimation of the latent class and the mixed model. Regarding some variables like pricing fee, the first item here, you can see that the increase in congestion pricing charges reduces the willingness to use personal cars in all 3 classes, where the second class is less sensitive than the other 2 classes, as you can see based on the coefficient. Or regarding travel time had different effects among these 3 classes, where the higher travel time of cars and motorcycles more likely only reduce the utility of car in the second group. For this group, however, the travel time of PT and semi-PT, pool taxi here you can see, decreases as the ride time increases. Surprisingly, however, this is the opposite of the third group. Regardless of higher travel time of PT and pool taxi, these modes have higher utility with respect to this parameter in the third group of the respondents. Well, using the latent class model also was motivating because we thought that we can identify that who belong to which group. So the result of class membership, well, it turned out that there are just two variables that we can assign to different groups. We tested all social demographic characteristics for a class assignment, but these two parameters turned out to be significant, which are being self-employed and having a bachelor degree. So the estimation of the latent class model allowed to verify that not all these parameters are significant for the population. For example, in the first and third class, only 5 and 4 parameters turned out to be statistically significant. And interestingly, the magnitude of the significant parameters also changed. We also tested the non-attendant attribute, assuming that attributes of time may have been entirely ignored by the respondents in 1 or 2 classes, where the estimates of travel time were insignificant. So, I mean, we tested attribute non-attendance as well, but the results showed the absence of this behavior. But interestingly, the result of the latent class model didn't improve the result of mixed logit model in terms of AIC and row score, the goodness of fit, indicating that the heterogeneity among the population has been distributed continuously rather than discrete. Given that the pricing fee is categorical, in our study, we calculated the marginal effect instead of elasticities. And this table presents the marginal effect of the cost of pricing in the mixed logit model. So you can see that if the cost of pricing increases by 1 unit, which is 1,000 toman, the probability of choosing the private car option will be reduced by 0.13%, given that everything stays the same, while the probability of using other transport modes will be increased, almost similarly around 0.03%. Okay, so I'm just wrapping up this. This study provided relevant insights on transport mode choice as a result of changing the flat-based congestion pricing into a hypothetical variable hourly based scenario. As I mentioned, this is the first modeling practice for Tehran's congestion charging, revealed the social demographic determinants of the mode choice behavior. And it turned out that frequent commuters to the pricing zones, individuals who live with low PT accessibility, and individuals with a higher degree have least preference towards PT mode, even in the revised scheme. However, senior people are more likely transit riders, either due to the discounted pension card or not owning driver license, particularly after the revised pricing scheme. Those with weekly permits and individuals with the irregular need to enter the pricing zone also will less likely use private car in future. And so with the increase in the number of entries into the congestion pricing zone, the utility of a SNAP, which is that on-demand platform, reduces, which is reasonable due to SNAP extra charge for the congestion zone. So the policy implication that we can draw from this study is that low accessibility and inefficient public transport system in suburban areas still is a barrier for more sustainable modes, and it necessitates more attention and investment, because we saw that those who have less accessibility to PT, there are still private car users even after implementing a variable pricing scheme. About the limitations of this study, well, the current study contains many limitations that need to be addressed and potentially addressed by future research. First, the respondents have been asked to choose their transport mode for a typical trip they usually make. So it's important that we ask a more sensible and more accurate information about their real trip information. Second, in this study, travel time and cost of various modes were not directly asked, and yeah, it was assumed that the respondents were aware of the associated attributes for all existing options. So we got this data from the secondary data sources that can be improved in the future study. And we are also extending this research by simultaneously controlling the RP data in the status quo, and hopefully for the next conferences or publication, we can present the complete model, which is a joint SP and RP survey. So thank you for listening to this presentation. I would appreciate if you have any question. Thank you.
Thanks, Ellie. It looks like you've got a question from Trey in the chat window.
Okay. Yes, Trey. The congestion pricing in Tehran is in place since 1979, which is almost 40 years. Well, I believe that every city has its own characteristics, and but I think, for instance, New York. Well, I haven't been in New York, but I assume that in New York also should be very monocentric like Tehran. And well, it really depends on the public transport infrastructure and other transport modes, and also travel behavior. It really varies between cities. That's actually that was one of the motivations that we did this study, because even though there are some other studies in place in the other cities, but we believe that Tehran has its own specification. But as a primarily investigation, I think, yeah, other cities can take away from this research, hopefully. Oh yes, about the software. No, I forgot to mention this. We use Elnaz to estimate the latent class model and random parameter model. Thanks, Matthew, for the question.
Any other questions for Ellie?
Oh yeah, there's another question. Oh no, well actually there was no improvement of latent class model compared to the random parameter model. Maybe I can share the screen again. The random parameter model yielded a better result. Let me share the paper. So here is the raw score of random parameter model. Again, you can see that it's 0.64. And this one is for the latent class model, 0.54. And well, but it's better if we compare AIC regarding that the number of parameters are different. Yeah, so you can see that the mixed logit model outperformed the latent class model. Well, I think I got your question a bit, sorry, it seems that I'm sleepy. Yeah, so Zhubing, you're right. We also suspected that latent class model might be better, but in this specific case, well, it was just a result of the data that we had. So the only thing that I can say is that the heterogeneity has a continuous characteristic, not discrete. So that's why the random parameter outperformed the latent class model. Yeah, it depends on the data, you're right. Any other question?
All right, if there are no other questions, this was our final paper. So thanks all for participating in the Bridging Transportation Researchers, the inaugural Bridging Transportation Researchers Conference. We have been recording this entire track, and track 1 is being recorded as well. So as soon as the video is processed, we'll probably do some light editing and then put them up online and share them out with everyone. So thanks again for everyone who participated today. Thanks to my co-organizers on the conference for making things run smoothly. Any final comments in the chat box before we sign off?
Only just we would appreciate if you have any feedback, any problem or any suggestion or recommendation for the future conferences. If you have, please share it on the Google group that we created, and I believe that those who have registered to the conference link, they have been added to that Google group. So if you are not in that Google group, please register. I will add you to that, and then please keep in touch for future conferences. And yeah, we would appreciate any recommendation and any feedback. Thank you.
All right. Thanks so much, everyone. See some of you at TRB, I'm sure.